Section 3.7, Derivatives of Logarithmic Functions. So we've seen how implicit differentiation gives us a technique to calculate derivatives of inverse functions. The inverse function of e to the x is natural log of x, so it makes sense to use implicit differentiation to find derivative rules for logarithmic functions. That is, all functions of the form y equals log base a of x. And remember, natural log is just y equals log base e of x, which we simplify as ln of x. And what we're first going to do is just recall some properties of logs. And what I want you to do is actually pause the video and see if you can figure out what any of these are on your own. And once you've figured out as many as you can what the logarithm rule that I'm looking for is, then you can unpause the video and check to see that I gave them to you correctly, or that you answered them correctly. So go ahead and pause the video now, and we'll go over these. Okay, so if y is equal to log base a of x, this one right here, this is logarithmic form, and what I want you to do here was rewrite it into exponential form. That is, if y is equal to log base a of x, then x is equal to a to the y. Okay? This base a is still the base here of the exponent, and then the y over here becomes the exponent. Now log base e of x, that's exactly what I wrote up there. That's just natural log of x. Log base a of m times n, if you have two things multiplied together inside a logarithm, you can split those up and add the two logs. And this comes from, it's the same thing with exponents, where if you multiply two things together that have the same base, then you add the exponents. This is the same type of thing that's going on here, but in the logarithmic form. Log base a of m to the n, the rule is that you can bring the exponent down in front, so that's n times log base a of m. If you're dividing m by n inside a logarithm, then you can simplify that by subtracting the two logarithms, log base a of m minus log base a of n. And now we have a bunch of cancellation properties. A raised to the log base a of x, that's just equal to x. Those things cancel each other out. And log base a of a to the x, that's just x. Another way of thinking about this is you can bring that exponent down. That's x times log base a of a, and log base a of a is just 1. So that just gives you x. E to the natural log of x is just this rule right here, but using e as your base, and then natural log of e to the x, that's also just equal to x. Log base a of a, as I mentioned up here, that's equal to 1. Natural log of e is also equal to 1. And then natural log of 1, that's equal to 0, and log base a of 1 is also equal to 0. These are all rules that I would expect you to know off the top of your head. So if you don't know those, you should review those. If you have questions about them, we can talk about them in class, or come to my office hours and we can talk about them. So the meat of what we're doing today, or in this lesson I should say, is we want to figure out a formula, a rule for the derivative of log base a of x, where a is some positive constant. It doesn't actually make sense to have a be negative, a negative number here. And what we're going to do is we're going to find dy dx, where y is equal to log base a of x. And the issue is we don't know how to take that derivative directly, so we're going to rewrite this expression into exponential form and then use implicit differentiation to find dy dx. So we start by writing y is equal to log base a of x. And according to the rules I gave you up there, this is the same thing as saying that a to the y is equal to x. And now I'm going to take the derivative of both sides of that. So that's the derivative of a to the y and the derivative of x. The derivative of a to the y, our rule for exponentials is that this is equal to a to the y times natural log of a, but then that's what I would do if it was a to the x. Because it's y, I need to multiply by dy over dx, doing my implicit differentiation, and the derivative of x is just 1. So now I can divide all this stuff to the other side, and I get dy dx is equal to 1 over a to the y natural log of a, and that's fine. The only problem with this is that if we originally start with an expression in terms of x, we want to get our derivative in terms of x. So what we're going to do is, instead of writing a to the y, we're going to substitute back in x for that expression right there. So this becomes 1 over x times natural log of a, and that is our derivative rule for log base a of x. It's equal to 1 over x times natural log of a. And then if you have natural log of x, you get this exact same expression, but your a value is now e, and natural log of e is just 1, so this just turns into 1 over x. So these are two more derivative rules you'll need to know. Notice that when you do the derivative of a to the x, you get a to the x back times natural log of a. Here it's a similar thing, but now your natural log of a is going on the bottom of the expression. And we'll stop there.